Assalamualaikum to Dr. Hamid. We are from group Indah Machinery and we are going to present about our report, and that is investigation machining condition for code subject BBO 10703 condition monitoring in machining. And this is our group mate name and card metric. First, we have HAZIM FAIZI bin AZMAN, and that is me. Second, we have QURRATUL NISHA binti ISMAIL. Third, we have Muhammad Daniel bin MAZNI FAIZAL. And lastly, we have Muhammad IRFAN bin IZHARI. Introduction to maintenance. Machines, buildings, and other service facilities are subject to deterioration due to their use and exposure to environmental conditions. If this process of deterioration is not checked, it may render them unserviceable. Next, I will pass it to QURRATUL NISHA.
Thank you, Azim. Next is smell. Smell of the coolant become offensive long before the coolant gets to be effective. Next is compounding. The cost associated with the wasting good coolant are the disposal cost of the getting rid of it. Increasing the useful life of coolant has a direct saving on the cost of manufacturing by reducing reducing the gas cost of the coolant itself and reducing the fees associated with coolant disposal. The cost of the smell pollution. First, most machinists would agree that a properly mixed high-quality cutting full the smell get pleasant because of not being maintained or cleaned after a while cutting flu and sting. After that is sting as a result of the growth of bacteria in shelter and the work done in the room. And then do not perform maintenance every month and do not change the coolant to a new one.
Okay, thank you, QURRATUL NISHA. Okay, next I will continue about pollution. The uses of cutting fluids, which are often manufactured with petroleum-derived chemicals with high ecotoxicity and low biodegradability, is to blame for the majority of this problem. Okay, next, respiratory irritation, asthma, pneumonia, dermatitis, and even cancer might result from exposure to these substances and the microbial growth they are encouraged. Mechanical machining causes is about exhaust gas pollution, which is machine tool, machining dust, welding fumes, and waste gas from painting are the three most prevalent waste gas pollutants in mechanical machining. Machine tool cutting and drilling powder tip is mostly the dust produced by metal powder on lathes, milling machines, and CNC machining centers. Next, wastewater pollution. Domestic sewage and machining wastewater make up the bulk of the mechanical machining wastewater pollution. Commercial wastewater, lodging wastewater, and office domestic wastewater make up the majority of domestic sewage. And last, solid waste pollution. Waste scraps, waste packing materials, waste emulsion, waste motor oil, waste cotton yarn, waste activated carbon, waste welding slag, waste paint residue, and decays are some of the most typical solid waste in mechanical machining. Mechanical machining is prone to the pollutant kinds outlined above. Next, there are many reasons which include low machining raw material costs will affected, high machining productivity, low machining labor costs, low profit added. Okay, next slide, I choose to Hazim. Thank you.
Okay, thank you, Izot. Next is I'm going to talk about noise on CNC milling. So users of computer CNC machines who are experienced with them are aware that noise will be produced when the high-speed spinning cutter head makes contact with the material. The knife on the tool is particularly prone to wear and breakage. When using a CNC machine tool, if the cutting sound is loud or screaming, it indicates that something is wrong with the machine's condition and allows for a quick analysis. So there are generally several reasons for this. To be precise, three reasons. Number one is abnormal noise. Is emitted as you're walking, which when you want to move the tool z axis or x axis, it will make a sound that is unpleasant or loud or like scratching. It have a problem with the machine. And the next number two is when the spindle motor is running, it will emit abnormal noise. So when the spindle is spinning, normally if like a good condition of CNC milling, lathe, it will not make any abnormal noise. It will go smooth. So if there's a problem with the spindle, so we need to check it whether it's a bearing inside it, wear, or it need to change. And the third one or the last one is using the wrong cutting tools or setting. When we cutting the workpiece, we need to make sure to select the real workpiece, cutting tools for the workpiece. We cannot do take it lightly using just one tool, or it will make the tool broke, or the workpiece will not have a good finishing. So that is why it is important to use the cutting tools or setting on the CNC lathe. Next is I will pass it to Daniel MAZNI.
Okay, thank you, Hazim FAIZI. I will talk about vibration in machining. Vibration. A mechanical phenomena known as vibration involve oscillation that take place around equilibrium point. A mobile phone, for instance, works properly because sound is the vibration of air. Vibration can be caused by unbalanced rotating part, uneven friction, the meshing of gear teeth, and other issues. But it is typically minimized by good design. Next. And why vibration occur during machining? Because they are not totally rigid, machine tool, workpiece, and tool might vibrate as a result of cutting force. Cutting performance may be constrained by the dynamic properties of the machine, workpiece, and cutting tool. Next. What are the different types of vibration in machining? Firstly is free vibration. When a mechanical system begins to vibrate initiation input, it is known as free vibration. It is the result of when you put back a charging pin and then let it go. After initiation, one or more is naturally frequency, the mechanical system dampen down to zero. Second is force vibration. When a mechanical system is subject to a time-varying disturbance, such as a wake, displacement, or velocity, force vibration takes place. The disturbance could be random, steady state, or periodic. Lastly is resonance vibration. System failure can be caused by resonance in mechanical system. As a result, vibration analysis must forecast potential occurrence date and provide mitigation strategies. Adding more damping or altering the stiffness of mass of the system to move the natural frequency away from the driving frequency can both dramatically lower the amount of vibration. In the event that the system cannot be altered. Possibly, the forcing frequency can, for example, by changing the speed of the machine that generates the force. Role of cutting force on vibration phenomena. For example, this cutting tool, cutting force and lack of tool strength cause vibration in metal cutting tool. In some situations, dynamic cutting force can lead to resonant vibration. This is how to minimize and control vibration in machining. First, use a cutting edge angle of about 90 degrees. Second, use a sharper cutting edge or a lower noise radius. Then increase the feed while decreasing the cutting depth. Modify the cutting speed. And lastly, improve your tool clamping system. And this is how to reduce vibration in milling. Choose the right tool. Cutting customers tend to alter the magnitude and direction of the cutting force in order to handle vibration issue in milling. First, selecting milling cutter with coarse pitch and clamping them with the least amount of overhang is recommended. Pick cutting edge with a positive geometry. Particularly when using steady line tooling, pick a milling cutter with a smaller diameter. Make your cutting edge radius modest. Choose grade of carburetor with a thinner covering. Use a larger feed for each tooth. For higher feed per tooth, slow down the rotation speed while keeping the table feed constant. Never lower the feed per tooth when there is vibration. Reduce the cut depth axially and radially. Utilize solid clamping system for milling cutters. Use the greatest connection size possible when working with modular tool holding system or using a taper tool. Lastly, place the workpiece center where the milling cutter will be and utilize up milling method. This is also example how to reduce vibration in milling. Start out with the standard cutting speed and feed. If vibration occur, progressively implement the following change. Increase the feed rate, increase the rotation speed, reduce the rotation speed, and reduce the feed until vibration disappear or at least is minimized. And that's all from our group, Indah Machinery. And thanks for watching our presentation.